now let's go ahead and remap all these values. So the remapping is pretty simple. You can just double click and type remap. You have remap numbers over here. So it asks for value, source and target. So inside value you can actually plug in distance, because these are the values that we want to remap. Source, in order to understand the source domain, you have to double click and type bounds. We are actually seeing this in the math tab. When I was explaining the math tab, you have bounds under your domain. Bounds right here. Bounds actually gives you the minimum and the maximum of a list of numbers. It gives you the domain, the min and the max of a domain. So that's what we'll do. Distance goes inside numbers, and you have the domain of this particular group of numbers. So the domain is 1.02 to 27.77. This goes inside source. This is the source domain that we want to change. And now we have to input the target domain, which should be controllable by us, because as designers and architects we should be able to control the output that we receive. So let's create a domain, let's construct a domain. So you can just go to domain and click on construct domain and bring this in, or you can just double click and type construct domain. This goes inside target, and domain start and domain end can have two number sliders. So you can just double click and type 0.05, press enter. You can copy this number slider by pressing alt, and you can just double click and change its floating point number values to 3. Click on OK. You can do the same for this. Put this inside domain start, put this inside domain end, and you can actually scale it, and you can actually keep the domain as somewhere over here. And after you have done this, now you can actually plug this thing inside the scale factor. So you have the factor. Now let's plug mapped inside scale, and you have something like this. Now the difference isn't yet noticeable, but if you play around with this, I guess we need to increase the domain end a little bit more. So I'll just double click and change it from 0.1 to 1. I also do the same over here. I'll change it from 0.1 to 1, because the domain start and the domain ends were too less. So that's why we are not being able to see any changes. So if I increase this a little bit, and slowly we'll start to see some change, and there you go. So you have a proper change right now. As you can see, I'll just turn the other things off. So I'll turn this thing off. I'll turn this particular thing off. I'll also turn this off, or maybe I'll just I'll turn this thing off, and there you go. We have exactly what we need. So as you can see, we have the count as 66. I'll increase the count a little bit so that this is very prominent. And now you can clearly see that this is actually a repulsor point. It's not an attractor point, but it's a repulsor point. So wherever you have this particular point, if you move it around, wherever this point goes, the size of the cells actually decrease. They decrease because we are scaling the distances accordingly. We are scaling the cell size according to the distances from this particular point and the centroids of each of these cells. So whenever I take this point to near to any cell, it actually increases or decreases the size based on what distance or how far it is away from all of these other points. So that's a pretty basic attractor point concept, and we can also change this using the domain start and the domain end. If you increase the domain start, it will pretty much be the same. If you play around with it, you can actually reverse it. So if I do something like this and increase the domain end, now this is a perfect example of an attractor point. Now wherever this particular point goes, the cells are bigger over there, and when it moves away, the cells are smaller over there, as you can see. So let's use this particular concept now to actually complete our script. Now what we need to do next is, I also want the same effect over here in its y-axis or minus y-axis. I want all of these to look 3D, and I want it to have a sort of a thickness or a sort of a volume. So in order to do that, what we can do is just double click and type the move component. You can bring in the move component to move all of these particular curves in a particular direction, and let's move it in the negative y-axis because that will actually give it a volume. So this is the y-axis. Let's move it in this direction so as to give it a particular thickness. So you can double click and type y and bring in unit y, which is the unit vector of y, the y direction. And you can also double click and type neg, which is short for negative. It will actually compute the negative of any value that you are trying to use. You can plug this inside motion, which is now the direction. Now we can also attach a number slider to this particular thing, but we need to be able to control the amount of thickness or extrusion that we actually want over here. So you can just double click and type multiplication. Let's bring in a multiplication component and attach this to factor, and let's have all the mapped numbers inside A. I would actually prefer if we move all of these curves by a distance of the mapped numbers. I want to be able to give them thicknesses based on the size that they have. So we'll be using the mapped numbers to move them, and I'll also double click and type something like 8.50 just to create a control through which we can actually control this. And let's attach geometry to geometry finally so that we can move it accordingly. Now as you can see, I have moved all of these things. Just to get a little bit of more clarity, I'll turn off all these points. Now, as you can see, I have actually moved all of these curves in the minus y axis, but I have moved them according to the mapped distances. So the cells which are larger in size have moved the most, and the cells which are smaller in size have moved very little. So you can actually change that by all of these things, as you can see. So after you are done with this much, you can also play around with this factor and move it accordingly. The more you increase the multiplication factor, the more these mapped values get scaled up, and the more they'll move in the minus y axis. So after you are done with this much, now what we can actually do is we can graft both of these values. So we have both curves. We have one curve over here, we have the other curve over here. We can actually graft both of them, and after grafting them we can loft them. Now let's understand why do we need to graft them. If you double click and if you type loft, bring in the loft component, which means I would actually like to extrude this curve to its, all the curves to their respective curves, and I would like to create a 3D between all of these curves. So if I just attach geometry to curves, it would create a haphazard, confusing thing like this. Now this is exactly why you cannot attach a flattened list to this particular input. So just do Ctrl Z and go back. So you would have to graft both of these outputs. So you can double click and type graft, bring in graft tree. Now this thing is actually located right here under sets. You can find this under tree. So exactly the way you have graft inside the data tree. So if you right click on this, you see you have the graft option. Now this is the exact same thing but in the form of a component. So you can select this and input it over here. Now your data is grafted, and you can also copy this thing and let's attach this over here, and now both of our data is grafted. Now we can turn off everything else that we have. So I would just go ahead and turn off everything else in the script. Now I have two sorts of curves. I have this curve and this curve. Now if I did not graft it, you would just understand what kind of a mess it would create if you don't graft the data. Since you have grafted it, now the lofting will happen much more better. So you can just hold shift and attach both of these in order inside curves, and once you do that, you see that the lofting happens perfectly. And now once you're done with this, you can also create the base surfaces of these top halves, which means these curves can be created into surfaces so that it looks better. So you can just double click and type edge surface, or you can just double click and type boundary surface. I think that will work better. Bring in the boundary surfaces component, attach this to edges, and these faces now will have properly created surfaces. So now you have all of these sides and you have the top halves, and let's turn both of these things off. After you are done with all of this, you can actually give it some color. Now in order to color geometries in Grasshopper, you can just double click and type custom preview. and bring in this component which says custom preview allows for customized geometry previews. Bring in this component. It asks for two things, geometry and material. So I'll just copy this whole thing so that I can color both of these things. So inside geometry you can plug in your loft, and inside this geometry you can plug in your surfaces. So now you have some kind of a color to your form. I'll just turn both of these things off. Now if you want to give it some individual color, some color that you want to give, you can attach a color swatch to both of these materials. So you can just double click and type swatch, and you can copy this and attach it to material over here like this. Click on this color and you can change the color accordingly. So if I want it to have a red color like this, if I want the tops to be white, they'll look something like this. So after you are done with this, you can actually play around with the entire script now and see how it reacts. So maybe I'll decrease this whole thing a little bit so that it looks a little bit better, and I'll also play around with the domains. So maybe I'll decrease this so that this part gets freed up a little bit. And after this I'll also maybe increase the count a little bit. The count is set to 100. I can double click and change the maximum value to maybe 500 and increase the count a little bit more. Now it looks much better. So you can actually create interesting forms like this, interesting patterns like this, using the concept of Voronoi and Attractor points. You can also go ahead and bake all of these outputs that we are receiving. So say I want to bake this entire thing, I want to take it into Rhino. Since you cannot select anything over here in Rhino, I would actually like to bake all of these things inside Rhino so that I can have some physical geometry that I can work with. So you can just right click on your output. If you want to bake anything from Grasshopper inside your Rhino viewport, you have to right click on that output and you have to click on bake. If you click on bake, it will actually ask you the layer that you want to bake it on. So you select any layer that you want to, make sure you group it and click on OK. If you do that, you see now you have all the geometries in Rhino. I'll just set it to the shaded view so that it's visible, and I'll also go ahead and bake off these things. So click on bake, I'll bake it in the default layer, I'll group it and click on OK. And now I have all these geometries inside my Rhino viewport. So I can just turn both of these things off, and there you go. I have these geometries inside my Rhino viewport. Now these things you cannot change using your number sliders. Since I have turned off my Grasshopper preview, I can only change whatever I can visualize using Grasshopper, only using my Grasshopper window. I cannot do it over here. These are baked geometries, these are fixed geometries. You can just go inside your rendered view to take a look at how this thing looks like. So this already has the Grasshopper preview turned on. So I'll just go ahead and select the whole thing and move it aside so that you can understand what it actually looks like. So this is my Grasshopper preview, and this is the Rhino preview that you have just baked. And you can actually select all of these geometries, but these geometries you cannot select because they are from the Grasshopper that you can actually view inside your Rhino viewport. So that's it for this topic. In the next topic, let's take a look at a really interesting concept known as metaball in Grasshopper. You can actually find metaball over here if you go to let's say the mesh tab, and if you click on triangulation, you have three types of metaball. So we'll actually take a look at this particular component in the next topic.